you may need multiple like iterations, maybe, but it's not only depends on your first guess. It also depends on whether the DN is steep or not. If everything is very smooth, then you will converge very quickly, because the variation is very small, right? Just your first guess may be wrong, but however, when you go to the certain elevation, then you will be very close to your final result. Then you will converge very quickly as well. Yeah, really.
How to check the result is that I can stop the
Iteration? Okay, so usually for all the like iterative process, you need to have some condition to say, okay, so it's converged. So there are two types of condition usually set up. One is the number of iterations. So you may assume, say, okay, so I think it will converge after 20 iterations. So that will be one. So I only want to iterate 20 times. And that if you reach 20 times, then you will stop. That's one possible condition that you can set. Second one is, as you can see, every time I can find out a new XYZ. Right? Every time I can find out a new XYZ. So you can calculate the differences between each iteration. If the difference is getting smaller and smaller and smaller, then you can set up, for example, distance or the threshold for the delta for the adjustment. Right? You can set up a threshold for the adjustment. And if the adjustment is smaller than your threshold, then that's the condition you set. It's converged. So for most of the iterative process, it's like that. You have two conditions to converge. Okay, so I want to actually talk about a question. Say, all right, how quickly it will converge? First, of course, your initial guess, whether it's close or not, it matters. The second is, well, if the terrain is smooth or not, or is steep or smooth, that also affects how quickly it converges. But the stiffness of the terrain, does it cause any problem? Will it cause any problem in terms of whether the process, ray tracing process, will converge or not? Right. I say yes, of course. The reason I ask this is the elevation that you have. Actually, it affects whether the ray tracing process will converge or not. Imagine this scenario. If the terrain is like this. And right now, you have an image. And you have a ray tracing to perform. And in this case, you may set elevation over here. And you find out the first intersection, for example, this is Z1, and then you find out, say, this will go way up here and to here. then this will be your second guess, Z2, and intersect over here. And this will go way down to here. Becomes your Z3. And you will intersect with your light ray. Here. And then go way out to here. Will be your Z4 and so on and so forth. Okay? So it will be like the iteration will be here and to here. Oh, sorry. Sorry. Right, so it will be Z1 and then go to here and then go to here and then go to here and here and so on and so forth. Okay? So the ray tracing actually has a limitation, which is if your terrain is too stiff, then it won't converge. As you can see, these will gradually converge to the center. But this one, if your first guess Z1 is over here, then because the elevation is too, the terrain is too stiff, then in this case, it's gradually getting, wow, it's going out instead of converging to the center. Okay? So that's the limitation of the ray tracing. Just for your information, that when you are performing ray tracing, well, the elevation, the terrain shape is also one condition that you need to pay attention to. It's not that always it can converge. Okay, till now, any question? That's pretty much about the general also replication process, top down and bottom up. And any question till now? Okay, so if no question, then let me ask one question. So two solutions, right? So bottom up, top down. And the bottom up is the more widely used one. Then why? Why the bottom up is more widely used and top down?
For me, it's easier. It seems easier to me.
It's easier.
Easier process.
Easier process, but the process is like, well, it's all the program is working on that, right? So is that the real trick there? Of course, that's one difference. It's easier, and because the ray tracing needs iteration, so multiple iterations. So maybe it costs more time to perform that process. And there's the other difference. There's another difference. But the main idea is still whether it's easy to perform or not. Alright, let's take a look at this part. Both of these require one interpolation. Well, not to, well, if you say the DN interpolation is preprocessing, then that's of course one. So, but however, beside that, there's one interpolation to perform. So one is for the bottom-up solution. you need to perform the interpolation over here. You need to perform the interpolation over here. Why? Because when you reproject a certain point to your image, then that XA and YA, most likely, it won't be the center of a certain pixel. You won't be at the center of the certain pixel. So you will be at a, you kind of random location on your image. Then in this case, you need to perform the interpolation to know what's the supposed square value for that certain location. So maybe you can use the surrounding 4 pixels to perform, for example, bilinear interpolation to do that. So, but well, you need to perform a certain interpolation over there because nearest neighbor is too naive. So don't just use nearest neighbor. All right. So, and then for the top-down solution, here, where should we perform the interpolation? As you can imagine, we start from the pixel, image pixels. So, like I said, this B point is a pixel, right? So, here, this part, I don't need to perform any interpolation because it will just, I will just iterate it through each of the pixel on the image, and then I can perform this process. But you can think about this. If for each of the pixel, I can find the corresponding object space coordinates. So and then I can know that that information should put at which location? XB and YB. But this XB and YB, most likely it won't be at the center of a certain pixel on your also image. Right? It won't be at the center of the pixel on your also image. So which means that you will get some information like this. So assuming this is your also image, and what you put over here is like for each of the pixel you just project it to this canvas, and then you will project it to here, 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 here. Something like that. You are projected to the also image like this because it's top down. So you are projecting each of the pixel to your object space coordinates, which is the map, the also image. So after that, you need to perform interpolation. You need to perform interpolation to find out the supposed square value for each of the center of pixel, those black dots. Okay? You need to perform the interpolation from those red cross to those black dots, which are the center of each pixel. So interpolation is over there. The mosquito wants to play a role. Oh, you guys couldn't see it. Okay? Yeah, that's okay. So these two processes, they both require one interpolation. For the bottom up is over here. You are going to have you can say random location, and then you need to perform the interpolation on the image. And for the other one, you have the also image. You put a lot of projected red crosses over here, and they may sit on random locations, and then you need to perform the interpolation over here to find out what's the supposed information for each of the pixel. Is there any difference between these two interpolation? Is there any difference between these two interpolation? Any difference between that? To raster data. And how about this one? The what?
All data is raster data,
Okay, the image is like a raster data already,
so it's more easy.
so it's easier to perform. Why do you mean by easy? Why is easy?
Because we can use the surrounding raster to do evaluation.
Yeah, to find the surrounding surrounding pixels, right? So the difference between these two interpolations is that for this one, you are performing the interpolation on the regular grid structure, on a regular grid structure. So it's easy to find the information that you want. But however, for this one, the information that you have is like scattered around, like kind of randomly at different different locations, those red crosses. And right now, you want to put that in and interpolate